Let there be light. The Big Bang, the moment that marked the birth of our universe. Everything we know, from the smallest grain of sand to the largest star, began from a single point, a singularity of infinite density and temperature. This point, smaller than an atom, contained the potential for everything that is and ever will be. It was a seed of unimaginable potential. Then, 13.8 billion years ago, it happened. The Big Bang, a moment of creation that set everything into motion. The Big Bang was not an explosion in the traditional sense. It was more of an expansion, a rapid stretching of space and time itself. It was an expansion, a rapid stretching of space and time itself, unfolding the fabric of the cosmos. In a fraction of a second, the universe went from infinitesimally small to unimaginably vast, a transformation beyond comprehension. As the universe expanded, it cooled, allowing the first particles to form. This cooling allowed energy to convert into matter, following the laws of physics, creating the building blocks of everything. The first particles, the building blocks of everything we know, began to form, setting the stage for the universe's evolution. The universe was in its infancy, but it was a time of incredible change and creation, a cosmic dance of particles and forces. The Big Bang is still happening today. The universe continues to expand and evolve. The universe continues to expand and cool, a testament to the incredible forces that brought it into being and continue to shape it. Galaxies began to form, stars ignited, and the universe took on the structure we see today. The cosmic web of interconnected galaxies stretches across the universe, a vast network of matter and energy. Dark matter and unseen forces continue to influence the universe's evolution, shaping its destiny. From soup to stars, the first elements. In the aftermath of the Big Bang, the universe was a chaotic soup of particles, a seething mass of energy and matter. Protons, neutrons and electrons, the fundamental ingredients for atoms, zoomed around in the intense heat, colliding and interacting. As the universe cooled, these particles slowed down enough to interact, allowing the first atomic nuclei to form. The first element to form was hydrogen, the simplest and most abundant element in the universe, making up about 75% of all normal matter. Soon some hydrogen atoms fused together under immense pressure, creating helium, the second simplest element, which accounts for about 24% of the universe's normal matter. These simple elements, forged in the heart of the early universe, would become the building blocks for everything else, the foundation of all matter. Gravity began to play a crucial role, exerting its force across the cosmos. It drew these elements together into massive clouds of gas and dust, setting the stage for the next phase of cosmic evolution. These clouds, called nebulae, became the nurseries for the first stars, where new celestial bodies would be born. Inside these nebulae, gravity compressed the hydrogen and helium, raising the temperature and pressure to unimaginable levels. Eventually, the pressure and heat became so intense that nuclear fusion ignited, and the first stars burst into existence, illuminating the young universe with their radiant light. With the birth of these stars, the universe began to take shape, setting the stage for the formation of galaxies and the vast cosmic structures we see today. Islands in the void, the formation of galaxies. While stars were igniting within nebulae, gravity was hard at work on a larger scale. It drew these early stars together along with vast amounts of leftover gas and dust. Over millions of years, these collections of stars, gas and dust coalesced into galaxies. Galaxies are massive structures, often containing hundreds of billions of stars. Our own galaxy, the Milky Way, is a barred spiral galaxy, shaped like a giant pinwheel with swirling arms of stars, gas and dust. Within galaxies, stars continued to form, live out their lives and die. Some stars ended their lives in spectacular supernova explosions, scattering heavier elements forged in their cores throughout space. These heavier elements would be crucial for the formation of planets and eventually life. Galaxies also interact and collide, merging to form even larger structures. Our cosmic cradle, the birth of the solar system. About 4.6 billion years ago, in a relatively quiet corner of the Milky Way galaxy, a cloud of gas and dust began to collapse. This cloud, called the solar nebula, contained the remnants of previous generations of stars, including heavier elements like carbon, oxygen and iron. As the solar nebula collapsed under its own gravity, it began to spin faster and faster. The spinning motion flattened the cloud into a disk, with most of the material concentrated at the center. This central mass became our Sun. The remaining material in the disk clumped together to form smaller objects called planetesimals. Over millions of years, these planetesimals collided and stuck together, eventually forming the planets we know today. Our own planet, Earth, formed in the habitable zone of the Sun, the perfect distance for liquid water to exist. Thus, the solar system was born, a dynamic and evolving system that continues to fascinate us. Section 5, a pale blue dot, Earth's genesis. The early Earth was a very different place than the planet we know today. It was a hot, molten world, constantly bombarded by asteroids and comets. Volcanoes erupted across the surface, spewing gases and lava into the atmosphere. Over time, the Earth cooled and the bombardment slowed down. Water vapor in the atmosphere condensed and fell as rain, forming the first oceans. The continents slowly drifted into their present-day positions, a process called plate tectonics that continues to this day. The early atmosphere was very different from the air we breathe today. It lacked free oxygen and was rich in gases like methane, ammonia and carbon dioxide. However, this early atmosphere provided the raw materials for the emergence of life. Simple microbial life began to form in the oceans, setting the stage for the complex life forms that follow. Section 6. Life finds a way, the spark of life on Earth. The exact details of how life began on Earth remain a mystery. However, we know that around 3.8 billion years ago, in the primordial soup of Earth's early oceans, the first life arose. These were simple, single-celled organisms, but they could replicate themselves. Life thrived in the early oceans, evolving and diversifying. Photosynthetic organisms like cyanobacteria evolved and began releasing oxygen into the atmosphere. This oxygen transformed the Earth's atmosphere, paving the way for more complex life. Over billions of years, life evolved from single-celled organisms to multicellular plants and animals. Life colonized the land, took to the skies and filled every niche on Earth. The diversity of life on our planet is a testament to the power of evolution. Section 7, From Dinosaurs to Us, a journey through time. The history of life on Earth is a story of both triumph and tragedy. Over billions of years, countless species have evolved, thrived, and eventually gone extinct. The fossil record provides a glimpse into this incredible journey through time. One of the most iconic periods in Earth's history is the Mesozoic era, the age of the dinosaurs. Dinosaurs ruled the planet for over 180 million years, evolving into a dazzling array of forms, from the mighty Tyrannosaurus rex to the gentle giants like Brachiosaurus. However, the reign of the dinosaurs came to an abrupt end 66 million years ago, when a massive asteroid slammed into Earth, causing widespread devastation and climate change. This catastrophic event wiped out the dinosaurs, along with many other plant and animal species, paving the way for the rise of mammals and eventually humans. Section 8. The Rise of Humanity. Our story begins. In the wake of the dinosaur extinction, mammals who had been living in the shadows of the giant reptiles began to diversify and evolve. Among these early mammals were the ancestors of primates, the order of mammals that includes monkeys, apes and humans. About 7 million years ago in Africa, the lineage that would lead to humans diverged from the lineage that would lead to chimpanzees, our closest living relatives. Over millions of years, our ancestors evolved larger brains, the ability to walk upright and complex social structures. The first humans, Homo sapiens, evolved in Africa around 300,000 years ago. From our African homeland, we spread out across the globe, eventually reaching every continent. We developed language, art, music and technology, soon becoming the dominant species on Earth. Our journey from ancient ancestors to modern humans is a testament to our resilience and ingenuity. Section 9. Our place in the cosmos, the universe today and beyond. Today we stand at a pivotal moment in history, where our understanding of the universe is expanding at an unprecedented rate. We have explored our planet in great detail, unlocked the secrets of DNA, the very blueprint of life, and even ventured into space, pushing the boundaries of human exploration. We are beginning to understand our place in the vastness of the cosmos, a realization that is both humbling and awe-inspiring. The universe continues to expand and evolve, a dynamic and ever-changing entity with new stars being born and old stars dying. Galaxies collide and merge, shaping the large-scale structure of the universe in ways we are only beginning to comprehend. Black holes, the remnants of massive stars, lurk at the centers of galaxies, acting as gravitational anchors, warping space and time with their immense gravity, creating phenomena that challenge our understanding of physics. As we continue to explore the universe, sending probes and telescopes farther than ever before, we are making new discoveries all the time, each one revealing a bit more about the cosmos. We are finding evidence of planets orbiting other stars, some of which may harbor life, raising profound questions about our place in the universe. We are developing new technologies to study the universe in greater detail, from powerful telescopes to space probes that journey to distant worlds, each mission a step further into the unknown. The universe is a vast and mysterious place, full of wonder and beauty, a testament to the boundless creativity of nature. As we continue to explore and learn, driven by curiosity and the desire to understand, we will undoubtedly make even more incredible discoveries, expanding our understanding of our place in the cosmos and the nature of the universe itself. The future holds endless possibilities as we continue to push the boundaries of science and exploration. Our journey through the cosmos is just beginning, and the discoveries we make will shape our understanding for generations to come.